advanced class. Let's go ahead and prep for this chapter 8 test so we can knock it out of the park. I got the study guide here. I'm going to show you how to do every each and one of these, and that way you'll be better prepared for the test. Starting with the first one, whoa, that didn't belong here. It says write 0.1 times 0.1 times 0.1 times 0.1 times x using exponents. Since we have 1, 2, 3, 4 0.1s, this would be 0.1 to the fourth power, and then 2x's make x to the second power. And that's it. Pretty easy, right? Let's go to number 2. It's a simplified expression. It says 9 to the second power times 9 to the fourth power. When my bases are the same, I'm allowed to add my exponents. So this is going to be equal to 9 to the second power plus fourth power, which is going to equal 9 to the sixth power. And you know what? I just realized, yeah, there we go. 9 to the sixth power. All right, let's go ahead and go to number 3. Number 3 says we got 9 to the fourth power to the second power. This is a power to a power. So the power properties, we multiply this. This is equal to 9 to the fourth power times the third power. And that's going to be equal to 9 to the 12th power. Next is number 4. This time we got a division problem. -4 to the sixth power divided by -4 to the third power. Remember, and I'm just going to kind of make these a little bigger here. I'm finding this a little bit hard for me to read, which means it's probably hard for you to read as well. I'm just going to make it a tiny bit bigger. All right, maybe the numbers just show up better. And let's see here. I'm going to move this. There we go. Now we got number 4. I'm not sure why that happened. There we go. So this is going to be dividing, which means we're going to subtract. We're actually minusing 3 down here, which means we're minusing 3 over here. And we know 3 minus 3 is 0. Anything to the 0 power is 1. And then we got -4 to the, and remember this has to be in parentheses, to the third power. Okay? Because 6 minus 3 is 3. Next is number 5. 7 to the 4th power times 7 to the 0 power times 7 to the second power. 7 to the 0 power automatically is 1, so I don't even got to count that in. So I could turn this into 7 to the 4th power, and since we're multiplying, that would be plus 7 to the second power. And if I wanted to put that 0 in there, I guess I could put plus 0. It's not going to matter any. This is going to equal 7 to the 6th power. And on the bottom, we have 7 to the third power. And now this looks really familiar, kind of like over here, right? We're going to minus 3 from this side because it's smaller, which means I minus 3 from this side. And this is going to give me 7 to the third power. This would be 7 to the 0 power. And anything to the 0 power is 1. And anything over 1 is itself. All right, let's go ahead and go to number 6, find the product. We're taking the number in front and multiplying it to everything inside. So 0.25 times 0.25x times 8x to the second power, that's going to equal, well, 0.525 times 8 is 2, I'm pretty sure. I'm going to bring the calculator out just to verify and show you guys that 0.25 times 8 equals 2. All right, and then we see that we have x to the times x to the second power, which means we have x to the third power. So this is 2x to the third power. Now we have to take this 0.25x and multiply it to -1.2. I'm going to play it safe and use my calculator again. 1.2 times 0.25. I'm pretty sure we're going to get something like 0.3. Yep, 0.3. So, and since this is a negative, this would be -0.3. And since there's no x over here to add on to this one, it would just be 0.3, -0.3x. All right, number 7 says simplify the expression. When we simplify the expression, and for those, I'm sorry, that didn't understand number 6, I took this number, multiplied it to everything in the parentheses. We call this distributing properties, right? All right, number 7, simplify the expression. I know that 5 is being used, that exponent is going to be applied to the 2 and the x. So this is going to be equal to 2 to the 5th power, right, times x to the 5th power. 2 to the 5th power is 2 times itself 5 times. Well, I could come over here and put 2 times itself to the 5th power, and that's going to give me 32. So this would be equal to 32 x to the 5th power, right? And that'd be it. It does say simplify, so we can't leave the exponents here. Over here, we have j over h to the 3rd power. Once again, everything is going to be, that 3rd power is going to get applied to the j and the h. These are not the same base. We do not subtract the exponents if they're not. All right, let's go on to, let's see, number 9. Factor the expression 6x to the 4th power plus 4x to the 2nd power minus 2x using the greatest common factor. We want to use the greatest common factor. When we do this in class, we took these and we broke them down. So that's the way I'm going to show you. I'm going to use some room over here. We got 6x to the 4th power. And that's going to be equal to, well, 2 times 3 equals 6, right? And then it's times x times x times x times x, because it's x to the 4th power. Now we have 4x to the 3rd power. Now it's going to be equal to 2 times 2 times x times x times x. And next we have a negative 2x. And there's no way to do that. You just have, well, 2, right? Because 2 times 1 is it, and then x. So where are my common factors? Well, we know 2 is a common factor because that's in every one of them. And we know x will be a common factor. And that's it. So now we're going to go ahead and put 2x that we factor out. And then inside is everything that's left. 3 with 3 more x's, so that's x to the 3rd power. So this would be 3x to the 3rd power. Then we're going to add, and this would be 2x to the 2nd power, because there's 2 x's left over. And then a minus, because that's a negative sign there, 1, because anything times 1 is itself, and we need negative 2x. And that would be our answer. All right, number 10 says evaluate 8 minus negative 7 times 8 over 7. If I evaluate this, well, this is really going to be equal to 8 negative 7 plus 7, and that equals 8 to the 0 power. Anything to the 0 power is 1. Remember, it says evaluate, so we're not going to leave it as a power. Number 11 says write 1980 in scientific notation. To write in scientific notation, I know the decimal needs to go after the first number. So we'll be taking it back 1, 2, 3 places. That means I'll have 1.980, right? And I don't put the 0 there, right? Times 10. And remember, we moved it back 3 places, so that's going to be when I make my number smaller, I make my number bigger here, right? So let's see, we're on number 12 now. It says write 9.42 times 10 to the negative 4 power in standard form. Standard form means the number. So that means I'm going to take this 9.42 and it says negative 4. Remember, when I make this bigger, I make this, going to make this number smaller. So in standard form, I'm going to be going back 4. So that's, probably should move this. This would be 9.42. Sorry, I had to sneeze there. So we move this back 4, 1, 2, 3, 4. For every time I have a space there, I have to put a 0. So my answer is going to be equal to 0.000942. All right, I'm on number 13 now. Find the sum or difference, write your answer in algebraic notation. Well, if I write these numbers out, I got, and that's what I like to do. I'm going to take this 1.4, put it to the fourth power. When I make this smaller, I make this number bigger. So this 1.4 is going to be moved 4 times, 1, 2, 3, 4, right? So that's going to be there. So let's see, that's going to be equal to, it's like 14,000. And remember, I'm subtracting here. This is 5.1 times 10 to the, looks like to the, I want to say the second power, but that could be the third. Might have to make this even bigger. Something that does look like a 3 to me. Some of these numbers are going to be, yeah, that definitely looks like a 3 to me. Hope I don't make any mistakes with any other ones. And I'm starting to think, yep, this is a 3 over here. I'm going to have to go and change my answer here, guys, because I realize that's a 3. This would become a 7. So I'm glad I double checked my work. That's a 7. I don't see, that one's labeled correctly. I don't see any others where the 3 was mistook for a 2. So yeah, that should have clarified all my mistakes there. So now we have, let's see, this would be 5.1. And since it's to the third power, we'll be going 1, 2, 3 with it. That'll put 2 circles there. So we're minusing actually 0, 0, 1, and then 5. So remember, now we're going to write this in scientific notation. We're done. My answer is going to be 0, 0, 1, a 9, and a 1. But to put it to scientific notation, I need my decimal here. So my answer is going to be 1.91. And then, let's see, how many times did I move it? 1, 2, 3, 4. So that's times 10 to the, I'm going to go to the fourth power. Because remember, I made my number smaller, so my exponent here gets bigger. So it should have been 1.91 times 10 to the 4. And now we've got, whoa, wait a minute. That's a negative sign. Glad I took a second glance. Sorry, everybody. This is subtraction, not not addition. Made a little error there. That's still going to be 0. Still going to be 0. This will be. Let's see. We'll have to borrow one, won't I? So I'll turn this to a 13. Put this to a 10. That'll make this one 9, and that'll make this 8. So now my decimal end up here. This is going to be 8.9 times 10 to the, let's see, I have to move this 1, 2, 3 times. So to the third power. That'll be my answer there, final answer. Let's go to 14 where we're adding. We'll do the same thing here. I've got 2.6, and when I, to the second power, I'm going to move it twice. So that's going to turn to 260. Then over here, I got 1.5. I'm also going to move it twice. So that's going to be 150. And this time we are adding for sure. I see that there. That's going to give me a 0, a 1, carry the 1, 410. And when I move my decimal twice back, that's going to be equal to 4.1 times 10 to the second power. All right, let's move on to number 15. Number 15 says, find the product or quotient, write your answer in scientific notation. We're multiplying this. So when I multiply this, I realize that I'm multiplying the 7 to the 2, and I'm multiplying the 10 to the negative 5th power to 10 to the negative 3rd power. Okay. When I do this, 7 times 2 is 14. And 10 to the negative 5 times 10 to the negative third, that's going to be 10 to the negative 8. Now remember, our decimal point has to be here, so that means I have to go back 1. So this is going to be 1.4. If I made my number smaller, I have to make this one bigger. But bigger for negative numbers means that it's going to go closer to 0. So that's going to be 10 to the, I'm thinking, negative 7th power. And that should be my final answer on that one. Now the last one, 16, 1.7 times 10 to the negative 5th power divided by 2.5 times 10 to the negative 4th power. This time we're going to have to turn this into a division, a fraction. Remember, we're not doing baby math anymore. So this would be 2.5 times 10 to the negative 4. To solve this, I'll be dividing this from this, but I'm also dividing these. I'm going to move my smaller number to, or my bigger negative number, which is a smaller number, here. So this is going to be, when I put these together, this will be 10, because we're keeping it in scientific notation. 10 to the negative 9 power. And then, let's see here. Now we're going to have, well, is that going to be negative 9? No, we're not multiplying. I take that back. We are not multiplying. So that means I'm going to be taking and adding 4 to this side and adding 4 to this side. That's going to be a negative 1. So now I've got to see what is 1.7 divided by 2.5. Let's see, 1.7 divided by 2.5 gives me 0.68. Now remember, the decimal has to be here, so we're going to have to move it 1 to make it 6.8. Don't forget that when we make this number smaller, we make this number, actually we made this number bigger, so we have to make this one smaller. And smaller means farther away from 0, right? So this would be negative 2. So this is going to be 6.8x, or 6.8 times 10 to the negative 2 power. Well, that's all of them. I hope that helps you prepare for the test. See you in class for grading. Have a good night.